Hello, my name is Alejandro and welcome to Interracial Physics. Today we'll be talking about kinematics free fall. And kinematics, to introduce free fall is when an object is falling under a sole influence of gravity. And in free fall it leads to two important characteristics. Free fallings do not encounter air resistance. All free falling objects on Earth accelerate downwards approximately at 10 meters per second squared. A big misconception about free fall is that all free fall objects accelerate at the same rate. The initial velocity, direction of travel, which means objects going up or is falling, amount of object as has been falling, mass, so a feather accelerates at the same rate as a piano when at a window. For real? Hell yeah. If air resistance is ignored, yes. There are a few conceptual characteristics of free fall motion that will be valued when using the equation to analyze free fall motion. An object in free fall experiences an acceleration of negative 9.8 meters per second, which is also 10 meters per second squared, and accelerates downward. Whether explicitly stated or not, the value of acceleration in kinematic equation is negative 9.8 meters per second squared, or also 10 for any free falling object. If an object is merely dropped as opposed to being thrown from an elevated height, then the initial velocity of the object is 0 meters per second. If an object is projected upward in a perfectly vertical direction, then it slows down as it rises upward. The distance at which it reaches a peak of its trajectory, its velocity is 0 meters per second. This value can be used on the motion parameters in the kinematic equations. For example, the velocity V final after traveling to the peak would be assigned a value of 0 meters per second. If an object is projected upward in a perfectly vertical direction, then the velocity at which it's projected is equal to the magnitude and opposed to the velocity at when it is returned to the same height. Then this ball vertically with the upward of 30 meters per second will have downward velocity of negative 30 meters per second. And to further your knowledge of 1D free fall, this is an example. As you can see in the Y, the V is increasing in the downward direction, and acceleration is gravity, which is also negative 10 meters per second squared. And you can use, for finding time, you can use a stopwatch to record the time and further on find acceleration or velocity using the equations Vx equals Vx naught plus Axt, or x equals x naught plus Vx naught t plus 1/2 Axt squared. And it is a demonstration of 1D kinematics free fall. As you can see in the y direction, as it comes up, it comes back down using the force of gravity. A ball is dropped from the top of a 73-meter tall building. How fast would the velocity be when it hits the ground? So, since it's going in the y direction in free fall, we're going to focus in the y direction. So we'll write down some components we already know. So we're looking for velocity final. Velocity initial will equal 0 meters per second. Acceleration can be negative 9.8 meters per second squared, and you can also round this to negative 10 meters per second squared. The answer will be approximate for both. And in this case,
is acceleration always 0 on a 10?
yes. In a free fall problem, gravity will always take effect in free fall, which will make it negative 10. So, and time is not necessary, since in the kinematic we're going to use, the last one, we're just going to make life more simpler and just use our distance and our acceleration and our velocity that we already know.
So instead of x, you're saying we need to replace it with y.
Yes.
Okay, teacher.
So we'll do Vy squared equals Vi squared plus 2AD. So our Vy squared will come down.
You mean VIF?
Yes.
Okay, teacher.
Then that'll
Do
be
I
zero.
get bonus point for that?
You'll get no donuts in this classroom, but you'll get your own confidence boosted. So let me do this
Okay.
problem.
Sorry,
One
teacher.
Square.
point.
I
Plus-
want donut points.
No one cares. We'll
Why
use
can't I
9 point.
get donut points?
Let me just explain this. Okay, now let me explain what I just wrote down. So as you can see, I just replaced what we already know. Sorry, bi is 0 squared in the equation plus 2a. We're going to use negative 9.8 and 73 for our distance. So
this is in the y direction, right?
yes, always it is always going to be in the y direction because it's in a free fall, and we're only focusing in the y.
Okay, thanks, teacher.
In this specific problem.
Please proceed.
So simplifying 0 squared, it will obviously be 0 plus, simplifying this, negative 9.6 meters per second, and just bringing down to 73. Simplifying that even.
Teacher, you forgot the square right here.
And can you explain to me why? And just bringing down to 73. Simplifying that even.
Teacher, you forgot the square right here.
And can you explain to me why it doesn't need the square?
For the first one?
Yes. Tell me why the square is necessary.
Because acceleration is meter per second squared.
Exactly.
Okay, well I need my donut points.
And then
You forgot a square too, so that's 3 donut points already.
let me do this.
Okay.
Teacher, gravity doesn't work.
Then will be 430.8 meters per second squared.
Thank you, teacher.
Square root both sides, and we'll end up with 37.8 meters per second. But don't stop there. Just since it's coming down, it will be going the negative direction, and that will equal our velocity final.
Teacher, I keep falling. This doesn't work.